solve the system of equations by graphing. Here, we're given two equations. Our first equation is y is equal to 2x plus 8. Notice that's just a linear equation. Our second equation is y is equal to x squared plus 12x plus 32. This x squared tells us this is a quadratic equation. So how do we solve this system of equations by graphing? Well, just like solving a system of linear equations, we can graph these two equations, and we want to graph them on the same graph. Then we look for the point or points of intersection. So let's go ahead and do that. We want to graph both of these equations. So let's begin by graphing the first equation. That means we want to graph y is equal to 2x plus 8. We said this is a linear equation. And notice this is a linear equation written in slope-intercept form. That means we can easily identify the slope and the y-intercept. So the slope is equal to 2. And the y-intercept is equal to 8. Now we can use this information to graph. First, we want to graph the y-intercept. So when x is equal to 0, y is equal to 8. We also know the slope is equal to 2, or 2 over 1. That means we can go up 2 and to the right 1, or down 2 and to the left 1. So if we go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, and down 2 and to the left 1. Here, we get the graph of the linear equation. Next, we want to go ahead and graph our second equation. So we want to graph y is equal to x squared plus 12x plus 32. And we said this was a quadratic equation. Now, when graphing a quadratic equation, there are a couple things that are helpful to know. One of those things is the axis of symmetry, or the line that goes through the vertex that divides the quadratic in half. To find the axis of symmetry, we use the equation x is equal to negative b over 2a. In this case, our b value is equal to 12. So we have negative 12 over 2 times our a value, which is equal to 1. Negative 12 divided by 2 is equal to negative 6. That means our axis of symmetry is x equal to negative 6. It also tells us the x-coordinate of our vertex. The x-coordinate of our vertex is negative 6. Now let's go ahead and find the y-coordinate of our vertex so we can plot the vertex. To find the y-coordinate of our vertex, we take negative 6 and we plug it in for x. So y is equal to negative 6 squared plus 12 times negative 6 plus 32. If we simplify, we get that y is equal to negative 4. That means our vertex is the point negative 6, comma negative 4. And we can go ahead and plot that on our graph. Negative 6, comma negative 4 is right here. Now we also want some other points to plot. So let's go ahead and create a table. That will help us organize our points. We know we already have the point negative 6, comma negative 4. And that point is our vertex. That means we want to pick some x values that are greater than negative 6 and some x values that are less than negative 6. So let's go ahead and pick x values of negative 5, negative 4, negative 7, and negative 8. Well, if we plug in negative 4 for x, we get a y value equal to 0. So we get the point negative 4, comma 0. And since negative 6, comma negative 4 is our vertex, negative 4 and negative 8 have the same y value. That means this is also equal to 0. So we have a point right here and a point right here. If we plug in negative 5 as our x value, we'll get a y value of negative 3. That means negative 7 also has a y value of negative 3. So we get negative 7, comma negative 3, and negative 5, comma negative 3. We graph our quadratic equation, and it looks something like this. Now, we said a solution would be a point where the two graphs intersect. So we're looking for their intersection. If we take a look, we can see that these two graphs intersect right here at the vertex of this quadratic equation, or the point negative 6, comma negative 4. so that's one of our solutions. They also intersect right here at -4, 0, so that's another solution. Notice this system has two solutions, -6, -4, and -4, 0. So now we found the two solutions to this system of equations.